Hi, hello. Thank you for coming. So we will geek out a little bit about engineering and system design and architecture. And let's, first of all, I will introduce myself. My name is Pavel, and I worked for 10 years in the industry. I'm a core engineer and a gameplay programmer, and also I'm Ole Hadash. And I draw a little bit of a map here so we can orient ourselves, because AA is, well, not very good defined term, right? So we have our indie developers, we have our AAA with huge budgets, and yeah, somewhere in the middle is our studio, one more level, and we are doing AA games. So we are not a small team, not a huge team, but we can do stuff. So what are you as a AA? You have a very strict budget, and your ideas are very ambitious. So you're trying to compete with the big boys, you're trying to compete with AAA titles, but you're not as big, and you are looking at a pile of an untested technology that promises huge, but you don't really know what will come out of it. So you have a small engineering team, but they are committed, and you have a dream of making a game that can compete with AAA, with big titles. So first things first, you start prototyping, and when you start prototyping, you have a lot of pressure from design, from everyone. So to start producing code, to start testing their ideas, there is a caveat here. You shouldn't write throwaway code. You should always try to make your code, even when you're writing a prototype, you should make it production ready, because you are also testing stuff. You are also prototyping stuff. You need to understand how your systems work. You need to understand how your architecture works. So you start, sorry, while design is testing their ideas, you're testing your engineering ideas. You're testing your architecture and your systems. And when you create a system, try to do it as a system and not as a feature. You will often be asked to do a feature, and we will see it in the next slide. You will be asked to do a feature, but at that moment you should know that this could be a trap. What they're actually asking for is an example of the stuff they're going to expand later. And you should be ready, and you should be prepared for that stuff. And yeah, so even though you're writing production-ready code, be prepared to refactor it later anyways, because that's always coming. So what's the lifetime of a system? First comes an idea from a designer, usually, and he will ask you a small thing, like, well, let's do a box that you can hit with a sword and destroy it. At that point, you should hear, let's create a system that can produce such objects. And what you do next is you build a factory that can produce this sort of objects. And you can see that from that little box comes out like 3 classes here. And from those 3 classes, you can actually start producing content. It will come later. So the first box will be produced in like first year of development. The content will come on the like 3rd year of development. But that shouldn't stop you from creating this factory first, because you will have other tasks, you will have other things to do. So it's better that it is ready. And yeah, and after that, at some point, they will tell you, oh, so now we're going to have not only boxes, but we also are going to have chairs, and we're also going to have all the different stuff that you can break. And then you're ready. You're ready at that point. Some examples of how to create some that sort of systems that are scalable, that are ready to be expanded, even with unexpected in mind. So this is an example of an event system. This is what we inherited from Ghost Runner, but we're using it in Valor Mortis right now. And it works through components. You have two components. We are working in our Unreal Engine. There are two components, and they define how they interact with each other through a subsystem. And they don't really know what actors and what behavior is expected on the top level, like what should happen. They don't know that. They only know about how to interact with each other. But that means that any behavior can be described later on the top level. So whenever a designer has an idea, like, okay, so we want those two objects to interact each other. They are in different parts of level. They do this and this and that. It's easier to define that afterwards. It's easier to define that when you already have a system of communication between those two objects, even though you don't know yet what are those objects. So we use components for that, and we use a subsystem to communicate between those. Another way of doing kind of the same thing, as an example, our interaction system. So you have an interaction handler, and you have an interaction point, and it's kind of the same thing. You don't know what is going to happen when you interact with a thing. You don't know what that behavior is. You don't know what feedback is going to be. You're just starting. So you create those two components that can directly interact with each other, and you create the system that allows you to parse data, to do all of that stuff, all the boilerplate, without actually defining any behavior on top of that. And later on, when designer has ideas, and he will, so you will be able to delegate this task to them. You will say, okay, so this is how you use this system. So this is the component, you put in an object, and here's how you define the behavior in blueprints, whatever, and they will be able to do that. Another very useful pattern, whenever you have a situation when you have a clearly defined spot in your game, a clearly defined spot in playtime, you know it's going to happen, and you know there will be different behavior attached to it, but you have no idea what this behavior is going to be. A good example is post-spawn actions and post-death actions that I'm showing right here. We know that enemies are going to spawn. We know that enemies are going to die, and we know there will be different behaviors attached to it. Sounds playing, animations playing, rewards dropping. So we create a system of slots, which are, you can think about them like code injections. So you have a pipeline of code that is executing, and at some point you have a specific point where you can inject this sort of small behaviors that alter the experience a little bit. They are really powerful because you can create them as a small chunks, really easy to handle, really easy to maintain, because, reminder, you have a really small team and you need to care about that. You cannot maintain thousands of different pieces that are created as features. So those small chunks can even be created by a designer. They are exposed to blueprints, they are easy to handle, and they're really powerful. Just a small example of how to use them. I don't think I will stay on this slide for a long time, but there will be a QR code later, so you can download this presentation and check how to do that in your game if you want to. So those are all action usages that we have in Valor Mortis. Though this is just a top layer of stuff, not specific actions, but just like examples of what you can do with them. And we have like tens of them, maybe 50, 60 actions in the game. Some are blueprints, some are C++, but you can notice that they're all describing a very specific case. And these cases is what you need to identify as an engineer, as an architect. Like you need to see, okay, so here is a good point where a lot of different behaviors can occur. Like a lot of instances where like you want to add small strokes that are going to enhance your game a lot. Another way of doing a system, you can, and you probably should, do a data-driven system. So whenever you create, so this is, for example, our weapons. So our weapons are entirely described as data, so you can actually see everything about a weapon, and you can write anything about a weapon just with punching in numbers, just with punching in data in here. And this is a very powerful tool because it allows you to give designers a way of creating stuff and seeing it happen real time, because you don't yet know what they're going to create. You don't yet know what you're going to support. Expanding this system allows you to expand it for all the weapons that are going to be created, not only for the one that was requested. This is also a part of the same system, so those are animations, and we use tags to parse in and out animations. Whenever you have an ability with different weapons, for example, but we also use it for different stuff, you can use tags to specify what animation is going to play. And if you use a tag instead of specific asset, you can then easily expand it to any number of weapons, any number of instances that you're going to have in your game, because this is just a tag. And animation team can handle it from there. They know the system, they can input this newly created animation into your data asset with the tag specified, and they can see the results immediately, because the system is already created. So you will be able to give them this ability to create and see the results very, very quickly. So actually, that is it. And remember, when you are building as an engineer, so the flyway is not yet ready, and you're about to build it. Thank you. And here's a QR code that you can use to download it. Any questions? Sorry? How do I approach what? Casting? Casting? Oh, testing. Testing. We have a very powerful QA team on site. They are great guys, and they provide great feedback. So we're using tickets, and we use videos. They always record videos for us and describe steps and everything. Nothing fancy, but it works perfectly. That happens. That happens. So, for example, I have created a system once that was just, it was never used in the end. It was unnecessary. It happens sometimes, but at the same time, it's still, you gain a lot from that. So the whole action system that I showed here, it grew from that dead system. So you know that things, you will need some things. You should, as an engineer, you should still research the type of games that you're making. So you need to understand. So we are making first-person Souls-like game, and you can kind of expect what sort of things you, as a player, you will be able to do in that game. So you can expect certain things. And yeah, that system that I cannot name because it's dead. That system was never used, but the idea was still there because we still had to do some things. So action system was born actually out of that. So it's not always, it's usually not a waste of time. Yeah, so with weapons, you still have some common behavior. Like you have all the different sorts of guns, let's say, right? And they all can shoot, they all can reload, they have repeated behavior, and they have therefore repeated animation tags. So it is, you can think about it like a slot. So you have a slot, and in the code you describe, so okay, at that moment we want to play this slot. So player clicks reload, we want to play reload animation. We don't know yet what this reload animation is going to be, but we have this slot prepared. And when animation is ready, they come in, they fill this slot with their animation, and then they click reload, and it just works. Well, of course it never just works, but,
all right.
Yeah, you understand.
Great, thank you. And the second question?
One more thing I would add about those data assets. There is one caveat related to that. So when you're packing a lot of different assets into one list, into one data, it could be a little bit tricky to handle something like cutting parts of content out. So we encountered that when we were doing a demo. So whenever you cook packages in Unreal, whenever you have it all in one asset, it's kind of hard to specify, oh, we don't want to cook this, we don't want to cook that. So it could be a little bit tricky.
Okay, thank you. The second question is regarding how do you decide what kind, how generic the system you're working on is going to be. So, you know, when you have, you know, they tell you to work on a feature and you understand that you need to make it a system, how do you know just how big and flexible that system needs to be while, you know, maintaining the scope and managing to actually, you know, work on what's necessary?
Well, I think about it like whenever you don't have anything written, you have no code, you have infinite opportunities. So as soon as you start describing behavior in a system, you're reducing your opportunities more and more and more and more until you go to a specific implementation, and then you have to push a little bit after that to implement additional features. But that's fine. And you start small. You start small and you create a really solid boilerplate, like all the handling of like memory, data, everything. You make sure it is super solid, and you create like the most basic system that can produce this sort of asset that is required. So the easier, the more simple this system is, the easier it will be to expand it later, because you still have a lot of possibilities then. And yeah, as I said, also research. Of course, research. Always research, because if you don't know what sort of game you're making and what the experience is as a player and what is expected for that genre of game, you won't be able to create a good system. You should always research.
Thank you very much.
Thank you. Thank you.